Hello students of the CCS Academy 12th class physics. This is your video number 8 and it is your heading number 6 where we will discuss about the electrical field due to the multiple charges. Okay, before starting of this heading I would like to remind you that what I have explained you so far. I explained you about the electrical charges and fields. What is electrical charge? What is the source of electrical charges? What are the various properties of the electrical charges? After that, Coulombian electrical forces. What is the similarity and dissimilarity between the Coulombian electrical forces and gravitational law of Newton? And after that we discuss the electrical forces due to the multiple charges. And now in the last video I'm sure that we explained about the electrical field, the concept of electrical field, and I calculated it for the multiple charge, what are the direction of the electrical field as well as the various factors associated with the electric field. In this heading, as you know, I am discussing about the electrical field due to the multiple charges. We did the same thing. We did the same thing, student, in the case of electrical forces. What we did there, first we calculated the electrical forces due to two charges and then we shifted for the multiple charges. The same logic will be applied here to calculate the electrical field due to multiple charges. Okay, before starting of this heading, I am going to tell you the numerical aspect of these headings are also very important. I will discuss it later and I will provide you as a worksheet at the end of this chapter. So now I am in the mid of this chapter, so I am going to explain you about this heading and theoretical aspect of that, not the numerical aspect. Okay students, as you can see in the video that the sixth heading which I am going to tell you about is the electrical field due to the multiple charges. Okay students, the logic or the principle I will apply to calculate the multiple charges the logic I will apply to calculate the electric field due to multiple charges will be the same as we did in the case of electrical forces, and that is superposition principle. What is superposition principle? I told you so many times in 11th class. The if two or more than two waves meet at a point, then the displacement of the net wave would be the sum of the individual displacement. The same logic we applied in the case of electrical forces. Now come here. In figure what you are seeing, students, look closer. Q1, Q2, Q3 and so on. Qn are n positive charges. This n positive charges, and I want to calculate the electrical field at point P. What are the distance of this point P at from Q1? As you can see, R1. It is very simple since charge is Q1, so distance should be R1. So the symbol is not going to confuse you. Since charge is Q2, the distance is R2. Since charge is Q3, the distance is R3. Since charge is Qn, the distance is Rn. Okay, now come to the mathematical portion. In figure 6, as I explained you by the figure 6, the same thing is written in the statement. Q1, Q2, Q3 and so on Qn are the multiple charges. Okay, I'm not going to show you here the point charges because I told you so many times in the earlier video point charges will be treated here to calculate whether the electrical forces in the last videos or the electrical field in this video are the multiple point charges, you can say, and P is a point. I told you when I was explaining you in the last video number 7 about the electrical field, the two things is important. One thing is the charge and another thing is the distance or the point at which you want to calculate the electrical influence. Mathematically or physically it is called as electrical field. Okay, are the multiple charges and P is a point. As I told you, the logic behind this point P at which electric field is to determine. Okay students, where symbols have their usual meanings. Okay students, this is your, as you know what is the meaning of that. I am not going to write everything, what is R1, R2, Rn. So what I will write, I will write the famous statement as I told you in the class so many times, where symbols have their usual meaning. Okay students, now I'm going to shift to the further part of this heading on page number 10. As I told you earlier, which principle I will apply to calculate this? Which principle I will apply to calculate this? Definitely it was by superposition principle. Now come to electric field at point P. Now what is E? E is the vector sum of E1 plus E2 plus E3 up to En. I'm going closer. It is not visible to you, then it is definitely, students, En. Okay. Why I'm using vector? I told you in the last video, electric field is not a scalar quantity, student. It is the vector quantity. The vector sign is present on all the quantities. What is E1? Since we calculated electric field due to the point charges, the vector E1 is Q1 by 4 pi epsilon naught R1 square into R1 cap unit vector. I told you in the 11th class, when you want to convert a scalar quantity to vector quantity, you have to multiply it with the unit vector. So R1 is the unit vector. Where is the unit vector in figure? If you can ask to me, I am going to tell you. Look here. This is the distance R1. So in this direction, unit vector R1 cap would be. This is the vector. Whole value is R1 and the direction is from Q1 to P. Okay, then R1 cap, what is, you look here, R1 cap is the unit vector. As you can see from the symbol, it is the symbol of unit vector. So this unit vector is here. Now come to E2. E2 would be just like E1. Look at what is E1, Q1 by 4 pi epsilon naught R1 square R1 cap unit vector. So E2 would be Q2 by 4 pi epsilon naught R2 square R2 cap. Similarly, I'm not going to write E3. It would be similarly, if you could write that, Q3 4 pi epsilon naught R3 square R3 cap. It is not present, but I'm saying that on the basis of E1, Q1 by 4 pi epsilon naught R1 square R1 cap. On the basis of E2, Q2 by 4 pi epsilon naught R2 square R2 cap unit vector in equation number 3. On the basis of this two, you can also write E3, E4 as well as. So I am going to generalize it. What is En? En is Qn by 4 pi epsilon naught Rn square Rn cap, and this is your equation number 4. So I have the value of E1, E2, En, and I have to put in equation number 1. So what I am writing here, from equation 1, 2, 3 and 4. On putting in 1 instead of E1, I have this value from equation number 2. Look students, this is E2 present here, E3 present here, it is not present here, E1, E2 are present there. As you can see, it is easy to put up. We have done so many times in the exam, so it is not a very tough task to you students. You can do by yourself. But the logic behind that, why I are doing this, was the superposition principle. As we did in the case of electrical forces, I am doing in the case of electrical field as well as. Okay students, so there is no confusion. If you could see the previous video, you have the E1 value, you have the E2 value, you have the En value. Then from equation 1, 2, 3 and 4 we have E is here. E1 is the value from equation number 2. You can see the same value is there. E2 from value here, same value is there, 4 pi epsilon naught R2 square R2 cap, and so on. We have the value of Qn by 4 pi epsilon naught Rn square. If you could not see, this is your square students. Yes, square. Always square. By if there is square, then there also be square, because it is the logic of the electrical field we discussed in the video number 7. Last video I'm telling you, Rn cap. So this equation number 5, which I enclosed in a bracket, student, what tells you? This equation number 5 is the electric field due to the multiple charges. Okay, if you could remember the 10th class summation symbol, look here, this is the summation symbol. This is your electric field E, if you could see it, net electric field. As you know, as you can understand now, what is the heading of me? Heading of me and yours is electric field due to multiple charges. Then heading is going to come mathematically here, E summation Qi 4 pi epsilon naught Ri square Ri, okay, these are Ri, all Ri, and this I value is always from 1 to n. So I will summarize it, student, in the summation form. This is your equation number 6, and in equation 5 you have its expanded form, or where each and every term is written, and it is summarized in summation in equation number 6. So you can ask, what is the significance of 5 and C? First, I am going to tell you both equations are same. This is only the difference in writing. So you can use this way or you can use this way in short. Okay students, so I'm going to come in your main heading which I was explaining today, and I explained you in this video number 8, electrical field due to multiple charges. So what we have so far, we have electrical charges, their properties, electrical forces, the main formula of electrical forces, and electrical forces due to the multiple charges. In the previous video we have the concept of main electric field. It was very important concept and I will use later, and as well as important for your examination point of view. So you can write this as a notes, or you can understand by downloading it. Now in this last heading, I explained you electric field due to multiple charges, where we applied the same superposition principle, whose value is this, student. Look at this. Each and every term is written, summation is written. So I am going to finish it, video number 8 at your heading number 6. In later video, I will give you the next new concept of this chapter. Okay, student.